Bismillahirrahmanirrahim. Dear students, welcome you all to the Industrial Pharmacy theory class. As you know, today is our lecture number 13, and we are in the 7th week, first class of the online system, and the lecture number 13 entitled Contamination Control. In this lecture we will discuss in detail about the contamination in the pharmaceutical industries, different types of contamination which are very much hazardous to the formulation that is prepared in the pharmaceutical industries, and specifically we will focus on the sterile area and the different other areas. Contamination should be controlled in order to avoid the contamination of the product, which will not only affect the stability as well as efficacy of the product will be affected due to the contamination entry inside the formulation during the processing or in the finished product. The main objective of today's topic is to learn about the contamination and its sources, that what are the different sources of contamination that cause contamination of the product, and specifically we will discuss the personal work contaminants control, and what are the different personal bound contaminants and how they will control using different steps, and as well as in the final version of this lecture we will discuss the airborne contaminant control, and how they are controlled, which are caused by the air. Dear students, after the completion of this lecture you will be able to learn about the contamination and different sources of contamination in the pharmaceutical industry, as well as the personal borne contamination controls and airborne contamination or contaminant control. Before going to discuss in detail that how contaminations are controlled, first of all I would like to tell you about the contamination. In simple words, contamination is the existence of any unwanted or undesirous substances in the product, that may be in the finished product or it may be during the processing of the formulation, intermediate product, or maybe any unwanted substance that is not desirous in the finished product. Contaminants. Contaminants are the agents which cause contamination of the product, of the intermediate product, or it may be any unprocessed material may be contaminated during processing. Contaminants are the products or substances other than the product manufactured as per the specification or the standard operating procedures. Contaminants may be foreign products or external products that get entered inside the products which are unwanted. It may be particulate matter that are undesirous, which should be avoided in the manufacture of any formulation. It may be microorganisms, may be fungi, bacteria, viruses, which are unwanted, biological, or it may be endotoxin, that is degraded microorganism. Specifically, these are the gram-negative bacteria and products that causes the pyrogen. The main cause of pyrogen, that is endotoxin, that is the degraded microorganism, specifically that is the gram-negative, main part of the gram-negative bacteria and products, byproducts. There are different types of contaminants. The three main types of contaminants are physical contaminants, chemical contaminants, or it may be biological contaminants. The physical contaminants include fiber material, which are fibrous material or particles which are enter inside the particular formulation and cause contamination. That is the physical contaminants. For chemical contaminants, examples include vapors, gases, or moisture during the different processes in the pharmaceutical industry, or different chemicals which vaporize and cause vapors, and these vapors get entered inside the formulation, which are not needed and not part of the formulation, and causes contamination of the product. And biological contaminants that include examples like fungi, fungal growth in the formulation, fungal entry, or bacterial entry, or viral entry inside the formulation. Maybe the raw material during the processing get entered the fungus or bacteria or viruses, or maybe during the intermediate products, or maybe the final products during any stage. If biological contaminants get entered inside the formulation, because the contamination of the product, and product is deteriorated and stability is lost, and efficacy will be also affected. The physical contamination we can explain by a suitable example. If a leak in the holding contaminant or holding containment or holding container would contaminate the product inside it. If it is a leak, then physical contaminants, that I have already told you that fibrous material particles are some of the example of the physical contaminants. If the containment, that is the container, is leakage, and during this process of leakage the physical contaminants get entered inside the product, this would be an example of the physical contamination. And physical contaminants get entered. One example is the leakage of the containment, that is the leakage of the container, and in this way the physical contaminants become part of the product and that get inside the product, and that is one example of the physical contamination. In case of the chemical contamination, for chemical contamination, an example will be if I say that when the product is stored in a container that is previously held another product but was not properly cleaned, the remaining product's chemical composition may add impurities to the new product and causing it to become contaminated. I can say that during the processing, if I am going to mix the process of mixing, and during the mixing, if the mixture is not properly cleaned and there is a previous batch contaminants or particles or traces are there, and I'm going to mix prior to the approval of the cleanliness SOPs is not properly followed, and the previous batch particles, that is the chemicals, get entered and that become part of the new formulation or product, and which is not desirous, and then the remaining product chemical composition is added as impurities to the new product, and then by this way the chemical contamination of the product get occurred. That is a simple example of the chemical contamination. That may be the vapors, maybe included that I have told you that there are different chemical contaminants like vapors or gases or moisture may be affected the formulation, and this is the example of the chemical contamination. If it is not properly cleaned in the previous batch, particles or previous batch chemicals are there during the processing, and by this way the chemical contamination occurs in the product. The last one, that is the biological contamination. For biological contamination, I can say that bacteria may be thrive if the container is not properly cleaned and dried, and it's contaminated by bacterial growth may occur. And the container, if it is not properly cleaned and cleansing SOPs are not properly followed, and it is not checked for the cleanliness properly, then it is contaminated by bacteria. If the product container is not properly cleaned, and it is properly cleaned but not dried, then it also there is some chances of the contamination by the bacteria or any microbe. The contaminated container will then affect the product, and microbes may thus introduce to the batch of the product, and the batch is affected, and microbial growth will be there in the product, and by this way the biological contaminants cause biological contamination of the product. So proper procedure should be followed to avoid the physical contamination and chemical contamination as well as the biological contamination in order to maintain the stability and efficacy of the product. It is essential part of the GMP and CGMP to follow the standard operating procedure CGMP, that is the current good manufacturing practices, in order to avoid the contamination of any type, whatever that is physical contamination or chemical contamination or biological contamination. It should be avoided, and the proper standard operating procedure should be followed to control the contamination. Another terminology that is widely used in the pharmaceutical industry, when you visit a pharmaceutical industry or you are working in a pharmaceutical industry, that unwanted introduction of one starting material or drug substance during the manufacturing, during the processing, to the other starting material or any other drug substance or intermediate products, and unwanted introduction of any material or the drug substance during the processing, during the manufacturing, or during the fabrication of any formulation, if occur, then it is termed as cross contamination. I have 5 ingredients in the formulation, and I am going to prepare the sterile formulation and any other formulation, whatever the tablet or the capsule, and there are 5 ingredients, and if any material or any substance, that may be the raw material or it may be the finished product, that become part of the product that I am going to prepare, that is except from the 5 or 6 material that is included in the formula, then that is termed as cross contamination. Then unwanted or undesirous products or undesirous starting material get entered inside the product or the starting material, and then become part of the formulation of the starting material. This is termed as cross contamination. There are different steps which are involved in the contamination control. Contamination control is important, and several ways why it is important. Contamination controls measure are one of the basic requirements for the manufacture of pharmaceutical products. If I am going to prepare any pharmaceutical products, and it is essential to control the contamination and to measure the control of contamination. It is one of the basic requirements in the manufacturing of any pharmaceutical product. Pharmaceutical manufacturing units and the pharmaceutical industries require a defined and valid system to avoid contamination. The proper control of the contamination and the proper system for the controlling the contamination and defined controlling and valid controlling. That is, it is valid, it is efficient control of the unwanted contamination, unwanted, desirous, undesirous, anyone, that is a physical or chemical or biological contaminant, should be properly controlled and should be properly defined and should be a valid SOPs for that. That is a valid standard operating procedure, that is a functional and efficient one. And pharmaceutical contamination involves the introduction of microbes into the pharmaceutical finished product. That is a pharmaceutical contamination, which may be physical, chemical, or biological contaminant. We will discuss the personal borne contaminant. Personal borne contaminant means that in the manufacturing area or any other areas, the filling area or any operation in the pharmaceutical industry, there are different personal working which may be men or women, which is get entered inside the pharmaceutical industry. That may be pharmacist, that may be any other expert or working women or men in the pharmaceutical industries. These personnel, sometimes a proper standard operating procedure for the personal borne contamination control is not followed. They cause contamination of the product by entering in that particular area with the contaminants, and the contaminants are not properly controlled, and in this case the personal borne contaminants get entered inside that area and cause contamination of the product. Personnel selected should be wear neat, orderly, and reliable, and he should wear such dress that is necessary for that particular area in order to avoid the contaminants. And the person selected to work on the preparation of parental products or sterile products or any other product must be neat, orderly, and reliable. He should be properly trained, and they should be in good health. The regular checkup after certain interval of several months, the medical checkup is done, and medical fitness certificates are given to the workers and the other professionals. That may be the mechanical or electrical or any other expert that is working in the pharmaceutical industries, or that get inside the formulation area or any other area in the pharmaceutical industries. That they should be properly checked for the fitness, and medical fitness certificate should be present. They should be in the good health. After checking medical fitness, it is ensured that it is good health, the person is good health and free from it. The person should also be free from the dermatological condition. If there is some physical, chemical, or biological contaminants on its skin or any part of the body, and it is not cleared and is not free from the dermatological condition, that might increase the microbial load or microbial growth and the product, and this should be avoided. Person should be properly trained and in order to avoid any contamination in the area. If they are exposed to some contaminants, and special precautions should be taken in order to minimize, in order to avoid any contamination in the area. Some points for controlling the personal borne contaminants are as follows. The personnel working in the area should wear fresh and sterile uniform in the aseptic area, a specially designed uniform in that particular sterile area, and any other area which need to be contamination controlled, and that is the personal borne contaminants should be controlled. And control this, the first step is to person which get entered inside that particular area, that is the aseptic area, that is free from the viable microorganism, and he should wear fresh and sterile uniform. There should be no particles, no other contamination, no dust, no any other fibrous material on that particular uniform, and he should wear any other personal protective equipment that is from this short abbreviated as PPE. PPE, that is the personal protective equipment. Suppose there is some type of dusting in the area, I'm going to discuss in general that he should use the face mask, he should use a gown, he should use any other related uniform which is necessary for that particular area. Minimum number of personnel in the clean area. If there are numbers increases which are not necessary, it should be avoided in order to avoid the personal borne contaminants in that area. For this purpose, the minimum required number of the personnel in the clean area. Suppose we need 2 persons in that area to work in that particular septic area, and there is no need of the third one, it should be avoided. The person should not enter clean rooms if the person have illness, illness that is maybe allergic condition or any other person that is with open wounds, he get injured, and there are open wounds, and the wound may cause contamination of that particular area, and that's why I told you earlier that properly and thoroughly checking of the medical condition of the personnel in the area should be done, and if a person is allergic, or he should get some flu or any other allergic condition, and if someone is with open wounds, he should not be allowed to enter inside the clean room in order to avoid any personal borne contaminants that get entered inside the product, and the contamination of the product is consequently resulted. No shedding of particles, and headgear or gowning, boots and gloves are to be worn, and proper dress, that is according to the standard operating procedure of the dressing of the cleanliness area of the septic area maintenance should be followed, rather than to wear any other or gowning or boots or any gloves. And movement should be slow. A person working in that septic area should be a controlled movement and slow movement, and in order to avoid any dusting or any other contamination, that is a physical, chemical or biological contamination. To avoid this problem, the person working in that particular area should slowly move, and their movement should be also controlled. No watches, jewelry and cosmetic to be worn. The person, that may be a pharmacist or the workers or any other related staff, he should not wear, or he or she should not wear any type of jewelry or watches or any cosmetics. Should be to be avoid any contamination. Second one, that is the airborne contamination control. First of all, I have told you about the personal borne contaminants, and next is the airborne contamination control, that air is also one of the source of the contamination in the pharmaceutical industry. The air should be clean, that I have told you in the previous lecture about the air control, that how air control and what is the significance of air control, and if airborne contaminants are to be there in the pharmaceutical industries and the specific aseptic area, then the airborne contamination should be controlled by using the maintenance of a hygienic laboratory. If it is unhygienic, then it is difficult to control the airborne contaminants. The air sample should be taken using the air samplers, and after that air sampler, that we have classified the different areas on the basis of microbial air classification, that is a class 1, class 2, class 100, 1000, and the different areas that I have told you. in the start of this tutorial chapter, and the proper maintenance of the laboratory should be also done in order to check the validity of the testing of the air sample, and the frequent disinfection of floor and surfaces should be also done internally. That's inspection of the floors and the surfaces or any other areas in the building should be done in order to avoid the contamination, that is airborne contamination. If the floors and surfaces are not properly disinfected and properly cleaned, then the air strike with the floors and the surfaces may cause the flow of that particular unwanted material, and that unwanted material by the processing of the air through the air, they get enter inside the product, and it is necessary to disinfect and frequently and thoroughly all of the floors and the surfaces by using the suitable effective disinfectant and methods of disinfection. The proper standard operating procedure for this disinfection should be followed in order to minimize the airborne contamination control in the product. The third one is minimizing the traffic in and out of the area. If the traffic in and out of the area, there is rush area, and it becomes rush areas, and there is unnecessary entry and exit of the personnel, and by this way the airborne contamination may be also resulted. And the last one is use of laminar airflow, that I have told you. Laminar airflow system, that is either of the vertical or the horizontal. These are the two different types of the laminar airflow system. In short, we can say that it is LAFS, that is termed as LAFS, that is the laminar flow system should be started. Then the detail of the laminar airflow system, the horizontal and the vertical, where the vertical is used and where the horizontal is used, that I have told you in the previous week lecture. You can consult from that as well. Use of LAFS, that is LAFS stand for laminar airflow system. Then I have told you that there are two main types of the laminar airflow system, that is horizontal laminar airflow system or the vertical laminar airflow system. And what is the significance or uses of the laminar airflow system? Laminar airflow system use 0.2 micrometer HEPA filter, that is the size of the HEPA filter used in the laminar airflow system, that is 0.2 micron. That I have told you that HEPA filter, that is a high efficiency particulate air filter, that having the efficiency to retain the 0.3 micron particle or larger than, and it is necessary to the pore size should be smaller than the 0.3 micron, because if it is more than 0.3 micron, then 0.3 micron and 0.3 micron more than 0.3 micron particles will be not retained, and that's why that is a laminar airflow system that use the 0.2 micron HEPA filter, and HEPA filter that is never use less than the 0.2 micron. If it is more than 0.2 micron, it is designed that HEPA filter, that is a high efficiency particulate air filter, that is was designed and installed in 1940s. That is briefly about history, that the HEPA filter was first designed and installed in 1940s. And minimum particle collection efficiency, that I have told you the efficiency about the efficiency of the HEPA filter, that is 99.97% efficient for retaining the 0.3 micrometer diameter particles or more than that particular size, that I have told you 0.3 micron or more than 0.3 micron particle, that may be the dust particle, that may be bacteria or any microbes, that should be retained. And use of the laminar airflow system is necessary to maintain and to control the airborne contamination control, and to achieve the class 100 area or class 100 condition, that is a highly restricted area or highly assured area, HEPA filters are required, and HEPA filter that is a high efficiency particulate air filter. These are installed in order to get class 100 area, that is the most critical area, and the positive pressure should be there in that particular area. That I have told you that what is meant by the positive pressure and what is the difference between the two different areas, and the highest pressure will be in the class A area rather than class B, and in the class B area the pressure will be more as compared to C, and so on. The class C area air pressure will be more as compared to the D. The highest pressure, air pressure, the positive pressure will be the class A area, while the lowest will be the class D area. There are some general guidelines that is responsible for prevention of contamination control, that we should follow some of the steps in order to prevent the contamination in the pharmaceutical industry. Test one material at a time to prevent cross contamination. If we are testing different materials and we are processing different material at the same time, we are mixing one ingredient and at the same time we are also involving in the same area the second ingredient mixing, then there will be cross contamination chances there, and we should also test one material in order to check any contamination or any other testing of that particular material. We should check only one material at a time in order to prevent the cross contamination. If we are testing two materials, then there will be chances of cross contamination, then our testing results will be not valid and not efficiently. We can claim with surety that this is the actual result. The second step is to take a sample in a room that has a suitable air control system to prevent contamination through airflow. The airborne contaminants should be avoided, and the sample should be taken in an area where a proper air control is there. If the proper air control system is not installed in that particular area where we are taking the sample, then there will be contamination chances. There will be any other contaminant become part of that sample, or the sample may be blown at the air to contaminate any other material as well. Use of the proper tool designed for the product. A proper tool should be used in order to test the sample, to take the sample. We have to use the proper tools and the proper equipments for that purpose, and ensure proper cleaning of equipment to prevent any biological contamination. That I have told you about the biological contamination, that I am going to mix a product processing of mixing, and the previous batch product or particle are retained on the mixer and it is not properly cleaned, and equipment, if I am going to process any formulation, suppose suspension is processed by using a suitable equipment or any other formulation that is biological contamination should be also avoided over there. Regular check if the cleaning process is effective. Cleaning process should be checked for the proper effectiveness. If it is not effective processing of cleaning, it should be wide and the proper validity should be done. The process should be optimized for cleaning as well as, and regularly checked for the effectiveness as well. Regular check equipment for wear and tear to prevent any compromise to its integrity. Sometimes the wearing tearing occur and the equipment, and that's wearing tearing, and the parts of the composition of the equipment become part of the material, and that's wearing part and the material, that is the composition of the equipment, then become part of the product, and by this way the product is contaminated. That is the physical contamination as well. Properly designed airflow system, that in order to prevent airflow contamination, that I have told you, that is the laminar airflow system. Wherever necessary, that is the vertical, or wherever necessary, that is the horizontal laminar airflow system should be followed in order to prevent any contamination, that is the airborne contamination. Dispensing stations should have proper dust extraction system. The proper dusting should be removed properly from the area where dispensing is done, where the raw material is dispensed, and that is the first step in the formulation. That is the dispensing. The raw material is checked, and proper dispensing of the only one at a time, one material is dispensed in order to avoid cross contamination and the raw material, and it is necessary to be a proper dusting system and dusting removal system and their dispensing area. Another step in order to prevent decontamination control, and don't return used sample to their original container. If we take some samples and then we test it, and then we again return this one to the original containers, maybe during the processing, during the testing, or during the exposing to any other environmental condition, the samples that we have taken earlier have the chances of contamination. If we return that particular sample that we have used already, that we have processed, we have tested, we have checked, and it may be contaminate the remaining quantities that is in the original container. So this practice should be avoided of the returning the used sample that we have used. Regularly monitoring the water to check for presence of microbial system. The proper checkup of the water that is used mostly in the cleaning purposes. But to check for the there is any microbial growth in the water, and we are desirous to clean by this water the equipment or any other machine, then by this way machine will be, or the areas where sanitation or any other area where the cleanliness is done by using this water, and it should be ensure that it is free from the microbial system or microbial growth in order to avoid any contamination that we are desirous to avoid. Another steps for prevention of the contamination control is we should avoid charging two materials at a time. That I have told you, that we will process, we will dispense at a time one material, or we cannot process at the same time the processing of two products at a time. We are processing, there will be cross contamination of the material as well. Avoid unloading different materials for different batches. It should be also avoided. At the same time, we should unload one material at a time in order to avoid cross contamination of the different batches. Line clearance should be observed during product changeover. If one product is completed, then each and every equipment that is used for that particular batch that we have prepared, and line clearance should be properly checked and properly observed, that the previous batch particles, the previous batch, any processing of the equipment or machine to be properly thoroughly cleaned, and there is a proper checkup of the testing of that particular machine or the line clearance. It should be keenly observed in order to avoid any contamination. Now that is the references of these points regarding the contamination control, whatever that is the personal borne contamination control or the airborne contamination control. These are taken from the references, the theory and practice of industrial pharmacy, 3rd edition, pages 660, 661, and Remington 2005, The Science and Practice of Pharmacy, 21st edition, pages 817 to 818. Remember that I have checked some of the assignments so far. There is some improvement needed in the references quoting at the end of the assignment. If you follow this one, it will be easy for you people, and in order to get understand, you can consult this one. And first of all, you should write the author name, reference class of the author name, and after that you can mention the year and the title of the book, and then the edition of the book and the pages. And some of the students has written one by numbering one for author's name, and then separately the title of the book, and edition is some cases missing, in some cases the student's assignment the page number is also missing. Try to uniform follow the references style uniform. If you are using two books during the assignment, it will be improve your assignment, it will enhance your assignment preparation efficiency as well. A little review about the today topic. I have told you that is a review that what we have studied in this lecture so far. I have told you about the contamination control, that what is contamination and what are contaminants, different types of the contaminants and types of contaminants, three main classes, that is the physical contaminant, chemical contaminant and biological contaminant. And after that I have told you in detail about that what is suitable example of the physical contamination, chemical contamination and biological contamination. If we are working in the pharmaceutical industry, then what will be the suitable example of these three contamination types. We have also discussed about the cross contamination and how the contamination controls are done, and what is the importance of contamination control. And after that I have told you about the personal borne contaminants and the pharmaceutical industries, specifically in the septic area, and what are the different points for the controlling the personal borne contaminants. Then after that I have told you in detail about the airborne contamination control, and how the airborne contamination control should be valid for the checking, and use of laminar airflow system. And finally we have discussed what are the general guidelines for prevention of contamination control and the pharmaceutical industry. Whatever the contamination, it is physical, chemical or biological contamination, if we follow these steps, these are the 13 steps, that is necessity to prevent any contamination and the pharmaceutical industry. And after that, the final, I have told you about references, that how you will provide references for the assignment that you have presented and submitted. Some of the students have some deficiency, and you can improve it in the next assignment as well. Thank you all for your attention, and I think so it is convenient to understand about this topic of the contamination control. We will discuss in detail in the online Google Meet class, as well as in case of any queries, any problem, you can ask over there as well. Thank you all for your attention.